In many ways, what we have done so far is revision, and I think it continues, from Maths Methods 3, but this is one of the benefits of doing it over 2 years is that you just get a second bite at the cherry sometimes and really consolidate. So if this looks like stuff that you've done in Methods/Maths Extended before, it probably is. But again, we'll try and deepen, we'll try and make the connections really strong for you as we go along. So the story until now, really, up until this point, is trying to get a handle on working out the sine, the cosine, or the tan of an angle. And we've never bothered, nor have we been asked to, work out what the angle is itself. This is really important. Often we don't need to. And up until now, that's what we've been doing. So we've effectively been working out those coordinates on the unit circle, okay, using all those principles. Now we're going to move to actually working out what that angle is. And 99% of the time, we are using one of those exact values. I should have had this up before. One of those exact values from your chart, from your information sheet, or ones that you can remember if you're lucky. Or draw a little triangle, which is what I do. But 9 times out of 10, we're going to get back to one of these angles here or a multiple thereof, okay? So that's effectively what we end up doing. So what we have here in 6E, and yes, 6D has been skipped, we will come back to it, is some equations, and we need to, in this case, work out what x is. So for question 1A, sine of x equals 1 on root 2. And if we have a look at our chart, if you just remember the textbook uses 1 on root 2, but it's the same as root 2 on 2, we can just go, was it sine? Yeah, it was sine. There's 1 on root 2 on 2. Up we go, it's pi on 4. And I just wanted to show you that you can, of course, use your calculator using the solve function, menu, algebra, and then there's the trig functions in here, or you can type in the word sine or cos if you're an idiot like me. Try that again. Sine of x equals, I'll go root 2 on 2 instead of 1 on root 2, but it's the same thing. So I'll go control, divided by to get my fractions, root 2 on top, control x squared for root 2, and 2 on the bottom. With respect to x, press return, and it's giving me a horrible answer. But we know it's pi on 4, yeah? This is what we call the general solution for x. You don't have to know how to do general solutions this year. I guess it must come in at Maths Special, I think, or something, but you don't need to know it for this year. So, how do we use our calculator to get the right answer? Well, the truth of the matter is that we actually didn't take into account a certain piece of information here, and that is for x between is a member of 0 to 4 pi. So that's 2 spins around the circle, yeah? 0 to 2 pi and then another 0 to 2 pi. What we can do in our calculator is we can specify a domain for the calculator to solve over. So if I go control equals, is that equals? Yeah. And then use this bar here, which if you say it out loud, you say such that. So solve this equation such that x is between, where's less than or equal to? Was it? Thanks. X is between 0 and 4 pi. That's how I tend to say it anyway. You can actually literally type in the words pi, letters pi, and it will do it as well. So solve this equation with respect to x such that 0 is less than or equal to x. That makes sense. X has to be bigger than 0. And x has to be less than or equal to 4. So this gives me the domain of 0 to 4 pi. Press return, and now I've got just the answers I'm looking for. Masterful. But I've got 4 solutions there, not just the one solution. Why is that? It goes around twice, Emily said. So that seems to maybe give us 2 solutions. Yeah, very comprehensively answered. So we can see here x equals pi on 4 is that first quadrant where sine is positive. X equals 3 pi is when sine is positive as well. That's between, that's the second quadrant. Here, that's beyond 8 pi on 4, which is 2 pi. So this is first quadrant again, and this is second quadrant again. So it's picked up all the pi on 4s between between 0 and 4 pi. Graphically, this is going to be a bit tricky for me to sort of do neatly, but graphically, we've kind of got between 0 and 2 pi, we've got this angle here and this angle here. So it's pi on 4 in here, and it's pi on 4 in here. And then for the next cycle through, so that's between 2 pi and 4 pi, we're going to have exactly the same spots again, but an extra 2 pi on. Okay, so the angle between the axis is pi on 4 here, and the angle between here and here is pi on 4 as well. But the overall angle will be 2 pi, which is 8 pi on 8 pi on 4, plus another pi on 4. That's 9 pi on 4. And this one is going to be 3 pi, which is equal to, sorry, not 3 pi. This is going to be 3 twos 8. I'm not doing this right. 3 fours 12 pi on 4 minus pi on 4, which is 11 pi on 4. So that's where we can see a couple of answers coming through here of 9 pi on 4 and 11 pi on 4. Okay, so what we are going to do now,